tutorial now. What questions? Yeah, what questions did you have trouble with?
Number 4 in there.
Density number 4. Cool.
Well, can you have the answers first?
I have to make the answers first. Are you okay?
I don't know.
Right.
I did try.
A 60 kilogram physics student is lying on the ground. There they are. Don't they look nice? They're square. They recall that air has a density of 1 kilogram per meter cubed. And the atmosphere is about 20 kilometers. And they estimate that they're about 33 centimeters wide and 1.5 meters tall. What do they estimate their pressure to be? Well, they think their pressure is going to be the force over the area, and the force is going to be the weight of the air, which is going to be mg over area. But we don't know the m, but the m is density by volume, by g. Oh, I only needed the weight? Oh, that's better. So then the weight is mg, which is density, volume, g. So let's just roughly do this in our head. This is about 1 times 0.33 times 1.5, and this is roughly about 10. I know it's not, I'm just doing it in my head. Oh, sorry, I left out my h as well, didn't I? For the volume. Yeah. Okay. G. I know it's 9.81, okay. I'm just trying to do it in my head. So this will be about 10 times 20, this is 200. Let me do it in my head, please. 10 times 20 is 200. 200 times 1.5 is 300. 300 times 0.33 is about 100. So it's about 100. What? I'm doing something wrong, is it?
That's 20,000.
Ah. 100,000 newtons. 100 kilonewtons.
Next to 1.5 to...
Let me just write this again. Sorry. It's 1 times 0.33 times 1.5 times 20,000 times 9.81. Yeah, but the student is just lying thinking about this. It's a rough calculation. Right, what one do we need next? Simple kinetic model. Yeah, which one? 4. What is that? Yeah, in this one I wanted you to use the formula energy equals 3 over 2 PV. That's 3 over 2. The volume is, a balloon is like a sphere. So that's 4 over 3 pi r cubed. And what's the pressure? 101,325. Oh, it's 30 centimeters wide. Thank you. Yeah, that's the answer then. Is that what you did? Good. Then you did it right. What's next now?
What? Yeah, I did think what?
What's next? Was that it?
Can I check the oral answers?
Yeah, I'll text you the answers once I've made them. Yeah. It's just like I said, it's been a bad week this week. Can we do some exam questions? You want to have a look at that? Which part? What type of questions are in that one? Yeah, but which type of mechanics questions? Ah, yeah, my fave. Right, let's have a look at that. Can you take out the questions you did with Connell then yesterday? Oh, Monica, so typical of you. Classic Monica move. Maybe KJ has it. Do you have it from yesterday? Bruce, do you have the questions from yesterday? Which ones do you want me to do? B2? What was B2 about?
What is B2?
A5 you want me to do? And B2? Is it? Yeah, I can do that. Bruce!
Hi.
I see you did the first one wrong.
Me.
Yeah.
Okay. Did you have?
Wait, which one am I doing?
Here,
Yeah. Yeah. Yeah, I can do that. Right. Guys, I'm going to look at what you did in the exam prep yesterday with Connell. You know Connell? Yeah. So, you want me to do part B. So, the child throws a ball upwards a distance of 15, at a speed of 15.6 meters per second. And the height here is 1.23 meters above the ground. What is the time taken for it to hit the ground here? U, V, A, T, S. What is U, Monica? Good. What is V? Don't know. What is A? 8.1. T? Don't know. It's what we want. S?
Yeah.
we got an S.
Yeah? So what's S here?
The maximum height is 30.
What's S here?
Minus.
And if you... Good. I was going to say, if you get it wrong, you're getting a slap. Because you know... You know dang well that the S is minus 1.23.
Yes.
Say no more.
Say no more. Continue. Okay. Yeah. Because I know what you did. You used the maximum height multiplied by 2 plus 1.23. Huh?
I got time for going out and
Yeah.
going for coming down.
Oh, the long way.
But I still, if the answer is still different.
Okay, well this is the way to be doing it. Right, what do we need to sing next then?
Beach, if
A5? Lammy. A5. You've got this deal here. T1. Oh no, that is not. Is it T? It's T just. T. T. Lee.
25. What?
Nothing. Lee, be good, okay?
Okay.
And oh, you're given the tension.
Yes.
It's 20.6 Newton. And they want the horizontal components of each piece of string. And you're also told the weight as well. It's, or are you told the weight? No, you're not. Okay, so this component here is 20.6 cos 25. And this one is the same. So whatever that is the answer. And then part 2 is what is the weight, the mass of the thing. So mg must equal 20.6 sine 25 plus 20.6, yeah, sine 25. So the m is that over 9.81. That's the answer. Is that not right or something?
Yeah,
It's right? Okay.
but with,
It's only like a 2-mark thing.
yeah, the perfection was doing,
This one?
yeah, that one.
Yeah, this one's a bit harder now because you can't actually use Lamy on this.
I was not to use some sort of knowledge.
Use turning force. Do you want me to do this one?
Yes.
Yeah. Okay, so guys, I'm going to do B2 now with the sine. Yeah. Let's have a look. I'll draw it for you. A uniform sine of width 80. So here to here, that is 1.4, okay. And then you have the weight here in the middle. Do we know the weight? We do. It's 2.5 g. So this is obviously 0.7 meters, and this is obviously 0.7 meters. And then you have a sine which hangs here of mg. Do we know this mass? No. We have to work it out. Do we know where it's hung?
Yeah, 0.8 meters from the end.
Oh, because the sine is 0.8 long.
Yeah.
So that means this distance here is 0.4. And it means this distance here is 0.3. Because, yeah, to the middle. And also there's this rope here with 120 newtons. We know that this is 0.85, so I can actually know this big angle here. The theta will be tan inverse 0.85 over 1.4. Can you just tell me what that is, please? Sean, are you looking at this one? Are you all looking?
It's
31.26 degrees. Okay, let's work this out. We want the, what is the only thing we don't know actually in this picture? The mass, which is what they want. So actually I don't think this, oh wait, I left out 1/4 on my picture. What did I leave out? No, I left out the reaction here. Huh? Yeah. So we need to resolve these into different components. So if I just draw this again here, this has two components, a horizontal and a vertical. And this one here has a horizontal as well and a vertical. So I don't care about the horizontal, I only care about the vertical. So this we'll call it RY, this we'll call it 2.5G, this is mg, and this one here is 120 sine 31.26. I'll take this as the turning point. This is clockwise, clockwise, anti-clockwise. So I can say 0.7 times 2.5G plus 1.7 times mg, is the distance to here, 0.3 plus 0.7, sorry, 1.0. That should equal 1.4 times 120 sine 31.26. So that means m will be 1.4 times sine, that means m will be 1.4 times 120 times sine 31.26 minus 0.7 times 2.5 times 9.81 all over 9.81.
So
7.15 kg. Okay, B, they want to know what the RX is and the RY. Horizontal at A, that's the RX. This is a great example where I think it's easier to do the next part first, the RY. Because I can know that the RY plus this should equal these two. So the RY plus 120 sine 31.26, that should equal 2.5 plus 7.14 G. Yeah. So then I can get the RY equals 2.5 plus 7.14, 9.81 minus 120 sine 31.26. What do we have for the RY here? 32.3 newtons. Okay, so how can I get the RX? Well, actually, I guess I misspoke. I think the RX is actually easier to get because the RX is just going to be the cost component. Cool. What else do we need to see?
A1.
A1.
the other A1.
The other A1.
The plan one.
Let's see.
AB plan.
What? What is he talking
A
about?
uniform plank AB and a boy sitting in one position and a boy sitting in
Oh! Yeah, this one, the plank. Actually, yeah, let's have a look. A1 again. A uniform plank AB is 2.48 meters long and has a mass of 15.6. So that's 15.6 G. And what did I say was 2.48? So that means this part here is 1.24 meters here to here.
Oh yeah.
is placed on a single support 1.05 from the end. So there's a support here, and this distance is 1.05. Yeah. A boy sits on the plank from end A. A girl sits on the plank from the other side. It could be a pivot, could be a string, doesn't really matter. It's an upward force.
It's an outward force.
Is it a force?
Yeah.
Oh, there's one confused.
Well, what else could it be?
I thought it's a downward force, so there's a three downward force.
No, it's positive. Zero.
What's it? Yeah, that's fine.
So the support is not.
No, the force passing through the pivot just means it's not turning. Doesn't mean it no longer has vertical force.
But it doesn't contribute.
Doesn't contribute to the turning force. Yeah. So we have a boy that sits here. And a girl that sits here.
Oh, you see, 0.5.
Oh, sorry. I know.
Yeah.
This is 0.35.
Yes.
And it's 30.8 G. And she, on the other side,
So we don't know where.
We don't know where she sits. That's why we are.
Now, KJ, this is an excellent example of bad or unclear English. A girl of mass 25.6 sits on the plank on the other side of the support. So at this moment it's not clear if they mean she's sitting here or the same distance or somewhere else. But if we continue to read, they want the distance the girl is from the end of the plank. So it means that we deliberately don't know because that is something we need to find. So we shall call this distance like here x. And we know her mass is 25.6 G. Okay. I will take this as the turning point. So this force, clockwise or anti-clockwise? Anti? Clockwise? Clockwise. Okay. Let's see. What's this distance here? That is 1 point. We know it's 0.7?
0.7.
0.7?
Yeah.
Oh yeah, 0.7.
Yeah,
I know that. Yes. We all know this. 30.8 G. That should equal, now what's this distance? Let's see.
0.19.
It's nice, man. It's nice that I don't have to think. Thank you. And then lastly, this distance.
1.06 not that one.
No, it's 2.48 minus 1.05.
Hang on, it's 1.24. No. Hang on, let me think. The total thing is 2.48. And this is minus 1.05. Minus x. 1.43 minus x. Okay, is that right now? Alright, so then you just solve for x.
Why is that 13.8?
What's 13.8?
That the boy.
30.8 is the boy's mass, isn't it?
How about the mass of the that?
We don't need to.
Why?
We have a G.
The boy sits on the.
Yeah, no, the mass of the plank.
It's 16.
Oh, yeah, there it is there. That's the plank. And this is the girl. And this is the boy.
Can we use any point as the turning point?
You know the answer to this.
Is a yes?
It is a yes.
Where?
But the support.
One is unequal. I mean, this is equilibrium. One is the president mentioned it is not balanced. Or
What's not balanced?
the plan.
If it's not uniform or it's not balanced?
Yeah, it is
Which?
uniform, not balanced. It's the same meaning, right?
No, it is not the same meaning. It's quite different. Uniform just means that the center of gravity is in the middle.
Mm-hmm.
Balance means it's not moving.
It's not balanced.
If it's not balanced, then they need to tell you something about the total turning force, because it won't be zero.
Okay.
Just in the same way that if an object was not balanced and it was accelerating, then they need to tell you something about the acceleration, because how else can you solve it then? Because you can't say the forces are equal.
And the power cannot be anywhere, right?
And the what?
The turning point.
The turning point can be anywhere.
But
Still,
in this
okay.
question,
Mathematically, it can be anywhere, even for this question.
but you're given a support. Like if you were to push the turning point, let's say in the middle,
Yep.
then what would the force of the support be?
You know what it would be, Monica, because it would have to equal 30.8 G plus 15.6 G
But
plus
you
25.6 G.
have the unknown. You have the unknown distance.
No, listen, you're not listening. You got something stuck in your head as an idea that it's impossible, so you need to listen carefully, okay?
Okay.
The up force provided at the support is not an unknown, it's a known. It must equal the three weights. Otherwise, the plank will be moving vertically. Yes. And so it's not an unknown. Anything else? Okay, so what else do we need to see here? This exam prep I gave you, it seems like the questions that cause the difficulty are the turning force ones. And forgetting some basic UVATS stuff. Monica, can you give this back to Bruce, but just explain to him why A1 is wrong? I'm sure you can see the mistake there. Wait, she's going to explain.
Oh.
You need the tutorial for this one next week.
Yep. Is that
Different kind of casting.
that was the last lesson? Yeah. Guys, what else do you need to see now? Well, I don't even know what that means. What else do you need to see?
Right.
Exam question teacher.
Yes.
Christmas exam question. We need that.
Exam question.
Can you take the next 5 minutes to work on the worksheet from today, please? Because it's ideal gas law, it should be so easy for you. Because I know Lorraine beats you when you don't get things right. So you should be really good at ideal gas law. Seriously, I'm expecting perfection.